Hello everyone, welcome back to the another session. This is what the continuous video of the previous one. We were already discussed about what is parallel algorithm and what are the different models of parallel algorithm. Though you have four different kind of models, shared memory model, distributed memory model, hybrid model, we were started discussion about the parallel model, and the thing also we were seeing how computations will be done using in parallel model. So we covered up to this, and we were discussed about theorem also, and continuation to that I'm adding this topic, which is recursive doubling. Recursive doubling is a technique that can be thought of as being a complement of the divide and conquer paradigm. Divide and conquer is a top down technique, and this was a bottom up technique. Now, the main idea is to start with small subsets and iteratively combine them in pairs until the whole problem gets solved. So what we'll do is we'll take some list of items. Let's assume that I'm taking some list of items. The main idea is what? We'll start with the small subsets. So we'll divide the whole problem into subsets, and we'll not divide it single. We'll divide into the n by log n parts. We'll divide these parts depending upon the problem. We'll divide, if you have n parts, you will divide into log n parts. That means you will divide the whole list into two parts, and we will be going to operate recursively or iteratively until you find the solution. That means the main idea is to start with the small subsets and iteratively combine them in pairs with the until the whole problem gets solved. Recursive doubling technique can be described by list ranking problem and parallel prefix problem. So in the last video we were discussed about list ranking problem. As far as this technique is also concerned, how we will be going to apply parallel algorithm technique to solve this problem is, we will be given with some linked list which is represented using array of pointers. Now we will compute the distance from the tail of each element in the list, because we will be dividing the half, right? The main idea is to assign a processor to each element in the list, and at each time step set each element's pointer to the pointer of its successor. We'll see with an example to understand. I'm sure you can understand with the example. The way how we will be going to do this one is, as far as list ranking algorithm is considered, you will be given with some list of items, and it is what your linked list representation, that you have some list of items and all these are linked like this. Now we will be going to solve this by dividing into subsets. Fine. So this is what list ranking problem. Now come to parallel prefix problem. As far as parallel prefix problem is considered, we will be going to take some list of items, and this problem will get solved by recursive doubling. Given a list of a1 to an elements of integer, compute all prefix sum. Sk is equal to sum of I is equal to 1 to k ai. This can be done in big O of log n time using big O of n processors. Let's take some example. Here I have list of 5 elements, 1, 2, 3, 4, 5. So what do you mean by prefix sum? We'll take the before character. Now let's see, as from the last topic of ranking problem, we were started from tail, right? Now what is the tail of this list? 5. So now 5 and the prefix of 5 is 4. Both will get, sum. We'll calculate the sum of these two numbers and we'll update this. We'll calculate the sum of these two. We'll calculate the sum of these two items, prefix. So this problem is what I wanted to calculate sum of that complete list. When you wanted to calculate, you will be going to divide the whole problem, and the work has been given to different kind of processors. We'll be going to apply parallel programming, and here we will be dividing the list into two halves. So this into half, this into half. This half we will have prefix sum here, we will have prefix sum here parallelly. So we'll take the other example, we'll move forward. Let's take that 16 numbers ka sum, that we will be going to take. So what I have to do is, before I take all this, I'll take two processors initially, P1, P2. Now what P1 will do is basically, we will be, before P1, P2, we will be dividing the list into half. Now what this list will do, we'll take prefix sum parallelly. So that means 16, 15 will, sum will get updated here, 14, 15 updated here, and 13, 14 will be updated here, 12. So all this prefix sum will get updated here, right? After that, so again the list, after you calculated this sum, again the list will get half. So that means this time you have to add the next two items. Whichever items already added, that will be added into the next cell. So cumulative figure, right? Still we'll go for the better example to take. Now here look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here what I am doing, I am taking 4 processor, P1, P2, P3 and P4. So P1 4 numbers, P2 4 numbers, P3 4 and P4 4. So all this sum will get accumulated. 1, 2, 3 sum is updated here. 5, 6, 7 is updated here. 9, 10, 11 here. So this is what actually prefix sum. This way we will be going to calculate, right? So that's it. We'll be going to talk about the example, which is binary tree. Parallel processing can significantly speed up the computation and manipulation of binary trees by dividing the workload across multiple processors or cores. Below, we'll be having some parallel processing strategies for constructing the binary tree, for traversing and for manipulating. That means you can insert a node into binary tree, you can delete a node from the binary tree, and we will be going to talk about these, how to construct a binary tree, how to have a traversal, and how I can insert and delete. Right, now let's talk about the parallel processing strategy, parallel tree construction, binary tree construction, and parallel tree traversal and parallel tree search and updates. Now, so basically the idea of binary tree we all know from the second year, that we will be going to consider the root element, and the tree will be going to construct it in such a way all the lesser elements of this root will be arranged in left side, all the greater element of root element will be arranged in right side. This is what the constructed strategy of parallel processing. That's what, right? Parallelly, you are going to divide the elements. Once after you find any element which seems to be lesser than the root, you will be organize the element over here. If it is greater, you will be get the element to this one. So it is left subtree, it is right subtree. The construction of binary tree will have two processings, P1 and P2. P1 is left subtree, P2 is right subtree. So here, dividing the data set into smaller sub data sets and construct the subtrees in parallel happens recursively. Recursive parallel construction. That means we'll divide the whole data set or whole collection of elements into smaller data sets or smaller collection of set, and we'll construct this subtrees, left subtree, right subtree. And we have a model here, bulk synchronous parallel model. So this model will help us to do the partition the data across multiple processes to independently construct parts of the tree and merge the results. Now let's talk about parallel tree traversal. That is, we already come across with three kind of traversal techniques. The one is what? Pre-order, in-order and post-order, correct? So we were come across with this pre-order, in-order, post-order. So that means traverse subtrees in parallel and combine the results. We'll be going to have a traversal technique and we will be going to print the result, correct? So now let's have some example to print this pre-order, in-order, post-order. Right. So now binary tree traversal is The process of visiting all the nodes in a binary tree in a specific order. There are several types of binary tree traversals: pre-order traversal, in-order traversal, and post-order traversal. We will be having even level order traversal also. Pre-order is what? We will visit the root node, then the left subtree, finally right subtree. What is in order? In order is we'll visit the left subtree, then the root node, then finally we'll visit the right subtree. So what is post order? Post order is we'll visit the left subtree, right subtree, and finally the root node. So level order is nothing but visit nodes level by level starting from the root. So this is what tree traversal technique of binary trees. So the constructing of binary tree, basically at most 2 children, right? A node can have, let's see some example. If I wanted to construct a binary tree, 30 will be here and 20, 10. 20, I mean this should be not 10, here it should be correct. 10 should be here left of this. So if you see this tree is constructed in such a way, 30 is in the root, all the leftover elements in the list have to be arranged in such a way, left should be smaller elements, that is 20 is left of 30 because it is smaller. 10 is found to be lesser than 20, that was it was smaller. So the next is what? Parallel tree search. That is what we will be divide the tree into subtrees and search them concurrently. Now half the way you can search an element in the binary tree. So how search operation, insert and deletion will take place? That you will be going to search the element. If that element is matches with the root element, then your search is successful. If the element is what you are looking for is lesser than this root element, then your searching will be at left hand side. If it is not, then it is right hand side, right? So this is what the idea of searching operation in binary trees. So inserting the element is also the same. When you wanted to insert the element, you have to insert the element in such a way that following the binary tree construction strategy, the element should never be violate the construction principle. That the construction principle is what? Left side should be the lesser than the root, right side should be the greater than the root. So this is what the computing binary tree using parallel algorithm. Thank you all.